assignments. Some of the material you see over here is kind of a very self-explanatory because this is something that you already done before in a different language. The only difference over here is that you have to tell what the type of data these variables are. So you can assume that A and B are both ints. Nobody says it here, right? So, so the here, what I wanted when it says explain with a full sentence and simple, with a full and simple sentence, what this is. So I want you to think about it. It's not a programming exercise. It's more of a thinking exercise. What's happening here? What is taking place? Don't tell me. You have to write it. Here's some Boolean expressions. Let's talk about what is a Boolean expression. A Boolean expression. Who can tell me what a Boolean expression is? Somebody else. You always give me the answer. Somebody, yes.
It's going to be true or false.
That's correct. It's going to give you true or false. It's logic, right? So here we have, this is what it's saying over here. Let me see if I can make this a little bit bigger because it's hunched out. There you go. Let's take a look at it a little bit closer to. There you go. A little bit closer. There, I like it that way. This is what it's saying. First of all, this is and. What about this over here? What is that? Very good. Let's have a exclamation mark. And what does it mean in logic? Boolean logic. Not. It says not. So think about it in a mathematical expression because Boolean algebra and algebra are pretty much similar to each other, numerical algebra. So the only difference is that next to each other? The parentheses by order of precedence says, right, no, it's and. Right, because you guys paying attention because then you're going to ask me. Well, no, maybe you know. Anyways, if you think about order of precedence as it was a regular calculation, and even though it's Boolean, think about algebra, you have two separate expressions that you are assessing if it is a specific condition. For example, the first one will be is A less than B. That's what it's asking. And then you want to put a not in front of it. So let's say A is less than B. Let's say, in fact, A is less than B. What is that? What do you get back from a Boolean expression that says that A, in fact, is less than B? True. And if you put a not in front of it, what do you get? False. So that means that if, in fact, A is less than B, that first expression, not A less than B, means false. Now let's take a look at the second expression. If in fact A is greater than B, that's true. But if you have a not in front of it, that makes it false. And now you're going to have the two of them next to each other, false and false. And what happens when two things are false? No. Everything is false, right? Everything is false. But here's asking you to simplify this. So it's not asking you to actually tell me if it's true or false. It's asking you, is there a way to tell? Is there a way to rewrite this expression in a simple form? And this is Boolean logic. So I want you to think about it, okay? The other operator that you probably never seen before is this one right here. And is the exclusive OR. What What does the exclusive or mean? Somebody define. What does the exclusive or mean? What is an exclusive or? How would you say it in plain English? Or, well, that's the inclusive or. So what would you add to that to make it exclusive? Right, only one of them. So if I added to Jordan, I would say if this is true or this is true, but not both. That's what the exclusive or is. And it's asking you to use the truth table. And then let's take a look at what are those links over here. Go over here. I spend a little time on this. And this is what I really would like you to do when you have the class. Here's the truth tables. Next time you come to class, you can spend time looking at truth tables. Here is a not. Because the not is expressed sometimes with different symbols. The most common to me, well, that's not true because I see a lot of logic in which they use the, what is that thing over there on the top? That is squiggle thing. Yeah. The tilde? Tilde? Yes. So, so in this case, when we only have one proposition, right? The truth table can only give you two possible outcomes, either it's true or false. So that's an easy one, right? Let's take a look at the next one. And if I can continue, oh yes, I can. Go to the next one. Go back right here. This is the not. So if the proposition is true, the not means it's false. I think we understood that already. You can look at it in terms of zeros and one also. And let's take a look at the or. So the or says that so what's that? Yeah. So the proposition is true. What's the T? Oh. Right, so the proposition kind of messed up over here a little bit, right? So the possible outcomes is that you have the proposition is either true or false. That one is not that clear. We didn't say over here it was true. Logical true. Zero validations, I guess. Okay. I have a bit of table for that one. Oh, okay. This is when it's true and when it's false. Okay, I see now. The proposition is true, then the answer is true. The proposition is false, the answer is going to be true because it's either one of the two then. As opposed to an and, then if the proposition is false, when it's true and false, then you, I don't know what the heck it's doing over here. Okay. Okay, here's the inclusive or. That's the regular or, the one that you always use. If I have money and if it's showing a good movie, we can go to, no, actually, the or. If I have money or they're showing a good movie, we can do both. Go to the movies and because I have money, something like that. That's the inclusive or. And as you can see, it has the little V looking up. As opposed to the caret, it's the intersection. Let's take a look at the next one. So now we have two propositions. So this one makes more sense in the or. I'm going to change those tables for the or. I'm not too happy with the way this blog presented. It's coming from a blog. Like I told you, I'm a scavenger and I take a lot of stuff from all different places. So, two propositions. How many possible outcomes can you have out of two propositions? Yes, four outcomes. You can say if the first proposition is true and the second one is true, then saying that P or Q is also true. That would be the example that I gave you. If I have money and there is a good movie, and I use the word and I didn't mean to say that. If I have money or there is a good movie, we'll go watch a movie. So here would be if I have money, but there is not that much showing a good movie, we're still going to go watch something. That's what this one says right here. Then I don't have money, they're showing a good movie, let's go watch it. Oh no, maybe somebody else is going to be paying for it. And here, well, I don't have money, it's not a good movie, let's not go watch it. Alright? That's the or. As you can see in the Venn diagram, you have everything filled in. Here's the and. The and is the intersection of the two of them. So the proposition is true, and the other proposition is true, then everything is true. Meaning, we'll go to the movies only if and only if I have money. That's what that means. We'll go watch a good movie. If the movie's good and I have money, then we'll go watch the movie. The other one says, the next one says, I don't have money. I have money, but there is no good movie. I don't have money, there is a good movie, we still cannot go watch it. Because neither one of them. I don't have money, there is no good movie, we're not going to the movie. Here is the complement, I think it is, or the nor. Nor means neither one of them happened. Okay? This is very rare to use, so I'm not going to spend any time with it. Is there any other one that I want to? I think I'm asking you to do the XOR. This is the XOR. This is the one in which I say, if one of the two is true, but not both, then we'll do whatever. An example of that will be, so I do have money, it's a good movie, but we're not going to do anything. I have money, or the movie is not that good, I don't care, we're going to go see something. I don't have money, and but there is something showing, so we're going to go see something, somebody's going to pay for it. And so the false over here is I had neither one of them, so nothing happening. So you have the solutions over here to the question. And get used to that because you will be getting expressions. Let's go back to look at answer number 4. Somebody else. Oh, can you answer number 4? What's that? It actually gives you a 3, right? Not a 3, 3, 3, 3. But look at the expression. Okay, this is no math. This is no algebra. This is in Java. What's happening here? For somebody who can say much. Yes, when you divide two integers, the result is another integer. And it truncates all the decimal parts. Okay? Automatically. We're going to talk about soon data data types, and so we're going to talk about that in particular a little bit more. But in this case, you need to know that in Java, when you divide two integers, you also get an integer. What's next? Escape sequences, and I see some of you already working on it. No, come up with your own. Don't screenshot anything. Don't copy and paste anything. Everything you have to do it yourself, even though it's available. Just because it's available doesn't mean that you have to do that. So come up with your own table. You can do it on text edit, you can do it in the actual text tab. It might not look as pretty, and it doesn't have to be a Venn diagram, by the way. I just want a table. Where did I go with escape sequences? Here we are. So I think I'm giving you here. Let's go over here to wherever I get. So I do have a website because in district keep on changing platforms, and I will be building all my lessons, and then it will go to a different platform, and I will lose it. So in the end, I end up with my own website, so you're going to get a lot of information there. Escape sequences. Escape sequences. Let's take a look at the table. Here's the table. Here's the table of escape sequences. We don't need to know all of them, but the most popular are \n and \t. I don't think I ever used much the other one, but you should know them. Who knows why this two sequence of characters, or special characters, or an alphabet, or two special characters, are called escape sequences? Yes?
Like otherwise they would escape the string and start turning into code.
No, it's never really related to Java or programming. It's something to do with a very historical thing that happened very, very long time ago. So you most likely don't know it unless you're one of those that feels like to look into things that happened at the beginning of computer science. So I told you that when I first started working, when I went to school, and then I worked on as a programmer, there was no internet. Actually, when I started working, they did have internet. But when I went to school, they didn't have it. So the screens were all black. Have you ever seen an old computer? I should bring an old computer, leave it somewhere here. An old computer, it doesn't have anything that you can use the cursor, the mouse. Okay? So if you wanted to do something specific, like for example, take a look over there. What did the \t do? Insert a tab. So let's say in my program, right, I want to, in this instruction of the syntax, I would like to insert a tab. So what you did is this. Look at the keyboard. Where is the escape key on your keyboard? Upper left corner. So we used to press two keys at the same time. We used to press escape and T, both at the same time. And then on my program, something very unusual that you could have printed. It was only on the screen. It will come up, and when you executed the program, you run that as a command, let's say, an instruction which was the tab. So this is quite a long time ago. I think it was Windows 95. Does anybody remember that? Oh no, that was before. I'm sorry, because Windows 95 already had this very interesting screen. It was before that. Oh, DOS. That's what it was. So you couldn't do anything. You had to use those two keys together. Why do we still call it escape sequence? Okay, it's just because we were so used to that and change it. And it's very typical in computer computer programming that you will encounter things that you wonder, you scratch your head thinking, why is it called skip sequence? Okay, the good thing is that it is a sequence of, you know, alphanumeric characters or special characters. But why is it called escape? And it's because of the escape key. So that was one of the many things that we had to do when we first started programming. So, because of that, I'm asking you to write, these are the ones that I use the most. And it says, here's nothing more than giving 2 examples, right? What next? Printer. So now you're going to have to actually do things with it. Where is it? On the website. Go to the website. I'm hoping that we stay with the same platform because as you see, as we progress in the class lessons, you'll see that I start transferring a lot of data, a lot of information is directed to Canvas because Canvas structure is good. So these are your what's the answer? I'll do this. So let me give you a piece of advice. Time is going to be over pretty soon. When you do the backslashes, the forward slashes, and other things, you're going to need escape sequence to do that. For example, if you want to print the backslash in your print statement, you have to have 2 backslashes, and that will print only 1 backslash. Okay? I think you have enough material to work for a little while. Do not, by the time we meet again, which will be next week, I want you to have finished with everything. And so we're going to do together the type of conversions, because that requires, yes.
Oh, okay.
Yeah, this is very touchy. Because all the way to the algo class, it's still have a hard time about type of conversion. So we're going to do that. So by the time we meet again, and I think it's Monday, I'm hoping that you finish with everything. The CAP printer is extra credit, unless it was tedious work, and I don't know if it really has a good purpose to it. I don't know. I leave it up to you. If you like ASCII art, that would be a good, nice exercise. If you also want to find how to do that in one of those websites that they generate the ASCII for you, you can do that. Okay? I know some students already have done one student I know who did that. So if you look for ASCII art generator in the browser, you will get a whole bunch of them. Find the right one. It's called ASCII. It's ASCII art generator. And we're going to talk about more ASCII in the future. Everybody have a good rest of the week. I'll see you Monday. You're welcome. Bye-bye. Yeah. Get out of the way. And then,
What?
yeah, because.
That was the one you stuck on the one.
No. Virtually self-service.
You skipped that.
Maybe trainer, right? What am I going to find?
Oh, yeah.
Go to Stereo.
Yeah.
After this, it works. Yeah. Yes, of course. Well, she was really yeah. You have a quick question?
Yeah, I can't like process
I Yeah.
Alright.
Oh, yeah. You know, it's no problem. It's a tough one. It's cool computer.
Yeah.
So, but I think, everybody who has a become how. Why didn't you want to bother me? I want to hear that again. No, you bother me. Right? You're going to say I don't want to bother you. Okay. Okay. What's your name? Okay. No, go ahead. Did you check that your Xcode works? Yes. When you're checking your laptop, that Xcode works? This is app development, isn't it? Yeah. Oh, honestly. You're looking at me like, I don't know. Okay, you're coming back. Because 77 minutes, right? Okay, go ahead, go. Jordan, come.